Hello, my name is Benjamin Michler. This is October 2015 for my degree in game design. I'm going to be looking at Newton's laws of motion and how they can relate to rockets. Sir Isaac Newton was born December 25th, 1642 in Worcester, England. Newton's work in the field of mathematics resulted in integral and differential calculus. His work in the field of optics even led to reflecting telescopes. He was instrumental in understanding gravity, but his most famous contribution came from the Philosophiae Naturalis Principia Mathematica. This introduces three simple yet vital laws used to describe the motion of objects on the Earth and in the universe. The first law, simply put, states an object at rest stays at rest, and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. Basically, anybody in a car accident's already experienced this. The other car or whatever object being the outside force that stopped you abruptly and hopefully didn't injure you too bad. The second law basically measures what the unbalanced or outside force can do to our object at rest using force equals mass times inertia. So Newton's third law, and the one I'll be focusing on, found here in this interesting little meme from Flickr, is for every action, there is an equal and opposite reaction. In other words, if you push a brick wall, the wall pushes back with an equal force, which exactly is what I'm talking about in rocketry. Like sitting in a chair, you're putting a downward force on the chair equal to the force the chair puts upward on you. However, I am going to be focusing on firing a model rocket, so that will convey on how we're going to explain Newton's third law. So, my daughter Zoe and I, we picked out that model rocket. I put it together. She didn't get anywhere near the engines or near the firing of the rocket at all, so she was safe. She did put the stickers on, though. And so you're going to see in the following video, the button ignites the rocket engine shoots a downward force on the launch plate, and the launch plate then sends an equal upward force onto the rocket, sending it blasting off into the sky. So here's that video, we can take a look. People on the road even stopped to view us launching the rocket at the park out here. And there goes my daughter now, retrieving the downed rocket. That was the part that she did do. And there she is holding it up. Alright. So how can this relate to my degree? Well, I want to say that almost anything could relate to game design in the fact that we could build simulations for almost anything that people have to learn about, or even, like here, rocket launch video games, or any video game really that could include physics. Even if it's fantasy physics, it still has to have a basis of set of laws. So all of this could apply, but most importantly, my daughter, after the final launch, said, "Hey Dad, we won." I asked her what she meant, and she told me that she meant that all of them fired, so we won, none of them lost. So it was a game to her. So in conclusion, my rocket was in rest and would have stayed there if not an outside force, the engine propulsion, had exerted a downward force on the plate, in turn sending an equal force capable of carrying the rocket off into the sky. All three of Newton's laws were applied by the launching of this rocket. I found that Newton's three laws expanded our knowledge of how the universe moves far more than any other scientist. He deserves all the recognition he gets, but one thing that blows me away, the truly smart people out there always they don't feel like they know anything. I found a quote from biography.com. One of the references cited, the quote follows: "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself now and then in finding a smoother pebble or prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me." Isaac Newton. I hope you enjoyed this, and here is the references. The photographic are in order of appearance with video and informational references. Thank you, and I hope you enjoyed this demonstration.